Now we have discussed about the subject CE 8395 Strength of Material for Mechanical Engineer. Unit 4 Deflection of Beam. The course outcome of in this unit is after successful completion of the students should be able to apply the stress distributions of shear and bending in various sections of beam. The knowledge level of in this beam in this unit is K3. So today we go discuss about the problem based on deflection slope. Four method will be we have used: double integration method, Mechalyze method, moment area method, and conjugated beam method. So these methods are using to we have calculate the deflection and slope. So that is the problem. A beam of simply supported 6 meter long, supported at its end, it's carrying a point load of 50 kilonewton at its center. The moment of inertia of the beam is equal to 78 into 10 raised 6 millimeter power 4 units. If the E for material of the beam is 2.1 into 10 power 5 Newton per millimeter square, calculate the deflection at the center. Calculate the deflection at the center. So that's the problem. So we can calculate the deflection and slope using the four method. So the problem will be not identified the methods, but so we have take it the four method to calculate the deflection and slope. So first of all, given data, length L is equal to 6 meter, we have converted to millimeter, 6000 millimeter, W is equal to 50 kilonewton is equal to 50,000 Newton, that is also converted to Newton. Then moment of inertia is equal to 78 into 10 raised 6 millimeter power 4. E is equal to, that is the Young's modulus, E is equal to 2.1 into 10 power 5 Newton per millimeter square. So that is the given data. So to find deflection at the center, deflection at the centers, that is the diagram also given. So AB, that is a simply supported beam, then point load will be applied, that is 50 kilonewton. So you can see this the diagram A and B and C. So that is the two supported. So that beam is simply supported beam. Point load will be applied 50 kilonewton. So first method we are using double integration method. First of all, we are using double integration method. Only we go find out the deflection. Slope will be not mentioned the problem. So we can see this the problem. Calculate the deflection at the center. So only we have calculated the deflection at the center. So first method we are using double integrated method. So the formula is directly applied. The simply supported beam point load will be applied on the center. You can using the deflection y is equal to directly apply the formula y is equal to W L cube divided by 48 EI. That is the double integration method formula. Simply supported beam point load will be applied on center. You can using the formula deflection y is equal to W L cube divided by 48 EI. So you can apply all the given values. So W of 50 into L 50 into 1000 and into L is 6000 cube divided by 48 into 2.1 into 10 raised 5 into 78 into 10 raised 6 equal to 13.74 mm. That is the deflection, 13.74 mm. Next method we are using Mechalyze method. That is also we have calculated the deflection of the center. So Mechalyze method, first of all we have calculate the reaction forces. So RA plus RC is equal to 50. So that is the total reaction force equal to total load. Only one load will be applied, that is a point load. So RA plus RC is equal to 50. So RA is equal to RC is equal to 25 kilonewton. That is also converted to Newton. So 25 into 1000, that is automatically converted to Newton, 25,000 Newton. Next, bending moment at x. So we have write the equations. Bending moment at x point. So you can write the equation ei d square y by dx square is equal to mx equal to, that is the bending moment at x point. That will be mentioned m suffix x is equal to rc into x. The reaction force into distance. So distance we have to take it x. So rc into x minus w x minus L by 2, W x minus L by 2. So we have mentioned the correct, the W load in the distance. We don't know actual distance. So the x will be, we are taking the moment distance. So the actual distance of the center point is L by 2. So we have reducing the x minus L by 2. That is the formula will be mentioned. W is equal to x minus L by 2. That is equation number 1. That is the diagram will be given. So A, B, C, the RE 25 kilonewton, RC 25 kilonewton, we have taken the x distance. So the center distance will be mentioned L by 2. So okay, the total distance is L. So the center will be at L by 2. So that will be, we have mentioned x minus L by 2. So integrating the above equations. So ei dy by dx equal to rc, x will be integrated x square divided by 2 plus c1. C1 is the integration constant minus w l minus l by 2 the whole power square divided by 2. That is equation. Next, deflection equation. First one is the slope equation. Next, deflection equation. You can integrating again. That will be integrated again. Ei into y is equal to rc x cube divided by 6 plus c1x plus c2. C2 is the integration constant minus wx minus l divided by 2 whole power cube divided by 2. That is equation number 3. Okay, that is equation number 3. Whole power 3 divided by 2 into 3. That is the equation, correct? The 3 will be not mentioned. W x minus L by 2 whole power 3 divided by 2 into 3. And next, applying the following boundary conditions are. So first of all, when x equal to L divided by 2 meter, slope is equal to dy by dx is equal to 0. So second boundary condition, we have x equal to 0, deflection y is equal to 0. So first, applying the boundary condition slope equation. So first boundary condition, we are using the slope equation. So we have find out the C1 value. C1 is equal to minus 1.125 into 10 power 11. That is the C1 value. First boundary condition, we have apply the slope equation. So we have find out the C1 value. C1 is equal to minus 1.125 into 10 power 11. Next, applying the second boundary condition in deflection equation. So 0, 25,000 into 0.3 divided by 6 plus C1 into 0 plus C2 minus 50 into 10 power 3, 0 minus 3000 whole power cube divided by 6. So C2 is equal to 225 into 10 power 6. That is the C2 value. So first of all, first boundary condition will be, you can using the slope condition, we find out the C1 value. Second boundary condition we have applied to find out the C2 value. Next, substitute the value of C1 and C2 and x equal to L by 2 equal to 3000 mm in deflection equation. So we are using the deflection equation, we have apply the C1 and C2 and x value. So deflection at center y is equal to 1 divided by 78 into 10 power 6 into 2.1 into 10 power 5 into 25,000 into 3000 whole power cube divided by 6 minus 1.125 into 10 power 11 into 3000 plus 225 into 10 power 6 minus 50,000 into 30,000 minus 3000 whole power cube divided by 6. So we have simplified all the values, we have calculated them, we got the answer of deflection y is equal to, that is a deflection at the B point. B is the center point, so we have mentioned the y suffix B. So deflection at the center point is equal to minus 13.74 mm. That is the deflection in independent of magnitude. Next we are using third method, moment area method. Moment area method. First of all, we have draw the bending moment diagram. Moment area method, we have draw the bending moment diagram. So that is the beam A, B, C. The load will be applied 3 meter, 3 meters. So 50 kilonewton will be applied. So that is the bending moment diagram. That is a bending moment diagram. That is a reaction force RA and RC. So the bending moment is divided into two triangles. So the bending moment is divided into two triangles for the sake of our similarity, to find the deflection at the center only. So only half of the section is considered. Only half of the section is considered. So the deflection at the center. So we have consider the half of the section. So area of this second section is equal to area of the second section is equal to, that is the second section, that is section 1, that is second section. So A is equal to half into 3000 into 25,000 into 3000. So that is the area of half into 3000 into 25,000 into 3000. Okay. So we have simplified that value. We got the area of second section is equal to 1.125 into 10 power 11 Newton mm square. Newton mm square. Next, center of gravity x bar is equal to 2 by 3 into L by 2. 2 by 3 into L by 2. So we know the L value also. So we have the 2 also cancel. 2 also cancel. We have apply the L value is 6000 divided by 3. That is x bar is equal to 2000 millimeter. Next, deflection at center. YB is equal to A into, that is a formula, A into x bar divided by EI. A into x bar divided by EI. So we can apply the all the values. A is equal to 1.125 into 10 power 11 into 2000 divided by 1.2 into 8 power 10 power 8 into 2.1 into 10 power 5. So deflection at center YB is equal to 13.74 mm. 13.74 mm. That is the value of deflection. Then next method, that is the last method also, conjugate beam method. Conjugate beam method. That is also that method is totally different to other three methods. Okay. So first of all, draw the bending moment diagram given beam. So ABC, that is the simply supported beam. You can draw the bending moment diagram. So you can see this, the value is RB 25 kilonewton, RE 25 kilonewton. Then load will be applied 50 kilonewton. So you can see the deflection on center, that will be a B point. YB will have calculated. So first of all, total load on the conjugated beam is equal to a formula, area of the M divided by EI diagram. Area of the M divided by EI diagram. So that is the, we have calculated the area of the that diagram. So P is equal to half into 6000 into 4.56 into 10 power minus 6. So we have calculated the load. P is equal to 0.01368. So we have calculated the load. Next, reaction at each support for the conjugated beam. Then RE is equal to RB is equal to 1 by 2 B, that is load, half into load. So we apply the value 0.01368 divided by 2. Value is 6.84 into 10 power minus 3 radian. 6.84 into 10 power minus 3 radian. Next, the slope at A. The slope at A. So theta A is equal to RA. So theta is equal to RA. So theta C is equal to 6.84 into 10 raised minus 4 radian. So deflection at B point, that is the center point B, is equal to bending moment at C for the conjugated beam. Bending moment at C for the conjugated beam. So we apply the bending moment on the C point. So 6.84 into 10 raised minus 3 into 3000 minus half into 3000 into 4.56 into 10 power minus 6 into 1 by 3 into 3000. 1 by 3 into 3000. We got simplify that values. We got the deflection at the center YB is equal to 13.68. 13.68 mm. So the conjugated method will be a values of small variation. Other three method will be 13.74 mm, but the conjugated method will be 13.68 mm. So actual values we have taken the 13.74. So we have calculated the deflection using four method: double integration method, Mechalyze method, moment area method, conjugated B method. So only we have find out the deflection at the center YB. The value of deflection is common for all method 13.74. Only small variation for conjugated B method 13.68. That is not a problem. That is also reached for 13.74. So the value of deflection is 13.74. The reference textbook R.K. Bensal, Strength of Materials, Lakshmi Publication. Then U.C. Jindal, Strength of Material, Asian Books Private Limited. Thanks for watching my video. Thank you.